So I'm Justino Rodriguez, and we're Team 4. I'm going to explain how the whole circuit works. In first instance, you can see here in the lab expressions, we have the count variable. And the idea is to have two buttons, one for the counter to go up, that is going to be this one. As you can see, once the button is pressed, only the counter increases in one value. And the other button, that is this one, is in a pull down configuration that is supposed to reset the counter whenever it's pressed. So it's a pretty simple scenario, just pressing and resetting. The LED turns on once 10 counts have been pressed.
Hasta 10.
Okay. And the other one is the other LED is light when the reset button is pressed.
I'm going to explain how we did the hardware connections. Obviously, we have the two buttons, and we decided to make a debounce circuit for each one of them. So we have first, they are connected to power in one terminal, the other one goes to the another node, which has a resistance to ground and two parallel diode and resistors. Both the resistors are of 10K, and they go to a node where they send the signal to our desired pin in the STM. But we also have a 0.2 microfarad capacitor that goes to ground as a discharge, and this is duplicated for each one of the buttons. And for the LED, it's an even simpler circuit. We only have the signal sent from the ST32, and we have the 220 ohm resistors for each one of the LEDs, and that's about it.
Hi, I'm Alejandro. For the hardware configuration and pinout, this is it. In the pinout view, we decided to not use the built-in LED nor blue push button, and so we connect our own by ourselves, and we set them in the pin name PV0 and PV1 for the LEDs. They are named LED 0 since the one is turned on when the count is up to 0, and LED 10. They do not have no pull up nor pull down since they are physically connected, and its GPIO output level it's in low at start. The PC4 and PC5 pins are for the push buttons in a pull down configuration. One is the reset and one is the control. And when we select it, it also blinks in here to tell the location. And we checked in the schematic the position of each of these pins in the actual board, so we can connect it, that it's in here. Some of them we connect them in the Arduino pinout, but others on the Modbus, I think what's its name. For the clock configuration, we leave it at 64, and we build a code which set up all these by itself. The other things such as the Cs, RCC for the clocks, etc., were the same as the last activity.
Hello, my name is Luis Carlos Ramos. Here we can see the UN32 variable, which means 32 unsigned variables, so we can count the number of states. Then we have last button state and button state. Basically, when we push the button, this state will change to 1, and if we keep it in 1, we're gonna count infinitely, like the amount of cycles that we're having. So we are checking if the states goes back to 0 to then here count the button. So we can see that the button states is equals to the read pin. If the button states equals the last button states, then we count. That's what we were talking about. Like we need that the GPIO states are different. Then here we have the GPIO reading pins, so we can so we can check if the pin number 4, the one that is the reset, is selected, then the count is in 0. Here we have the outputs. If the count is 0, then we set we set the first LED, and if the and reset the other LED. Then if the count is bigger or equal to 10, then the GPO pin is set, and if nothing happens, well, in which this case is something that the count is not equal to 0 but it's less than 10, then both pins are reset.